Hello and welcome to part 2 of the video tutorial on the 2009 Electricity and Magnetism exam, and we're looking at circuits now. So here Sean has he has a yacht with a 12-volt power supply. He has various low voltage devices that he wants to run off the power supply. He connects 3 resistors in series with the power supply as shown in the diagram, and we need to calculate the current through the circuit. So if we look at Ohm's law, I'll just grab the formula sheet. We have here V equals IR, and we can rearrange this a lot. So V is equal to IR, and we want to find the current, so we can just say that I is equal to V over R. And we know the voltage is 12 volts. And the resistance, because these resistors are all connected in series, the resistance is just going to be 2 plus 4 plus 6. 2 plus 4 is 6, plus 6 is also 12. So the resistance is equal to 12 ohms. So that means that the current is just going to be equal to 12 over 12, which is just 1 ampere. Sean connects an electronic game with a resistance of 12 ohms in parallel with the 6 ohm resistor. And we need to calculate the voltage across the electronic game. So again, we'll be looking at, put it there. So V is equal to IR, and the current for any part of the circuit is always going to be the same. But the current isn't just going to be 1 amperes like it was before, because we've added another resistor on, so we're going to have to calculate what the new current is. And to do that we have to calculate what the new resistance is. So we have I'll show you that. So this is series resistance here, and this is parallel resistance. Notice how it's all 1 over R, 1 over R, 1 over R. So if we do that here, we have 1 over RP, just so you know it's parallel, is equal to 1 over, so this is going to be 1 over 6, plus 1 over 12. And this is the same as saying 2 over 12, right, because 2 over 12 is just 1 over 6, plus 1 over 12, which is just 3 over 12. And that's also the same, 3 divided by 12 is just 1 over 4. So we now know that the parallel resistance is going to be equal to 1 over 4, 1 over the parallel resistance is going to be 1 over 4, so that means that that's equal to 4 ohms. So now we just need to add that in series with these two, because this is effectively a 4 ohm resistor that just goes across. So that's going to give us 4 plus 4 plus 2, so that's 10. So the total resistance is equal to, oh wait, that's 2. So the total resistance is 10 ohms. And we know that the voltage over the whole circuit is still 12. So V equals IR. The voltage is, we need to find the current. So the current is still voltage over resistance. The voltage is the same, the resistance is now 10. So that means the current is 1.2 amperes now. And to find what the voltage is across the electronic game, all we need to do, we have the current for the whole circuit, and we have the resistance of the parallel section here, which is going to be the resistance we need to use. So we just need to go V, I'll do it over here. So V is equal to IR, which is just going to be equal to the current, which is 1.2, times 4, which is the resistance of this parallel section here. So this is going to be equal to 4.8. So that's 4.8 volts. Sean switches the electronic game to standby mode. This causes the resistance of the electronic game to increase. Explain how this affects the voltage across the 4 ohm resistor. So, if the resistance of... I'll bring the diagram back. What we're saying is that this resistance here is going to increase. So that means that this parallel resistance is going to increase. And if that increases, then the resistance for the whole circuit will also increase. So we're just seeing resistance increase here, resistance increase everywhere, basically. And obviously, if we do current here, if we're seeing resistance increase, then that means the current is going to decrease, right? Because this is getting bigger. So let's say from this goes, if this goes up from 12 to 20, or let's just say that this section here goes from being 4 ohms to 6 ohms. Oh no, that's a bad example. Let's say it goes to 10 ohms, it goes all the way up to 10, so we'll have a resistance of 16, and the voltage is still 12. Then that's going to be much less than 1.2 like we had before. So that's going to be 0.75 amperes, or 1/4 amperes. So that's, as we see, increasing the resistance obviously decreases the current. And the current, if the current for the whole thing decreases, we need to find how it changes the voltage across this resistor, but the voltage is equal to I of R, or sorry, I times R. And the resistance on this resistor is obviously staying the same. Nothing's happening to the resistance of that resistor, it's just the whole circuit that's having the total resistance change because of the other section. So the resistance is going to stay the same, but the current is going to decrease, and that means that the voltage is going to decrease as well. So because the resistance of the game increases, and you can spend a long time writing a slightly longer answer to this, going through how I did before over how the resistance for the section for the resistor goes up, and then for this parallel section, and then for the whole circuit. But we just need to say the resistance of the game increases, so the resistance of the whole circuit increases. And therefore V equals IR, oops, oh sorry, you probably couldn't see much of that. So the current, or the voltage, across the 4, and it's the 4 and the 2 ohm resistor really. Resistors will increase. Oh sorry, the voltage is decreasing. Hopefully that makes sense. And this question here, it's asking you to describe the function of a diode, and diodes aren't in the level 2 standards anymore. But basically how diodes work is the current can only flow through one way. And if you read here, Sean is worried that he might accidentally connect the electronic game back to front. So he puts a diode in to protect the game, and that basically means that the current can only flow one way, so the game won't get damaged if he accidentally plugs it in backwards or something. So the function of a diode is to allow current to travel in only one direction, or to allow one-way current flow or something like that. But that's not important because that's not in the standards anymore. And that's the end of question 2, and I'll finish question 3 in the next video. See you soon.